Good morning, students. Welcome to physics video class. First, we are going to discuss about to move an object, push or pull, which is easier. Okay, this is a 3-mark question and a application oriented question. So just you see this topic, to move an object, so push or pull, among these two, which is easier. Okay, now we discuss this concept with the mathematical terms. Okay, when an object is moving with an angle, so angle may be between 0 degree to 90 degree. Okay, by the applied force, now the force is resolving into two component. Okay, so one is parallel component and another one is perpendicular component. Here the parallel component is considered as f sin theta and perpendicular component is considered f cos theta along the surface. Then so we have to calculate the what is the total force acting on the object. So to calculate this total force acting on the object, we have to sum of these two values. One is downward gravitational force, that is mg, then another perpendicular force, that is f cos theta. So adding this two value and we get the total force of the object to compare whether it is push or pull is easier. Now a very important thing, when the normal force is acting on the body, so it will be increases the force. Therefore in this concept there is no acceleration takes place in the vertical direction, that is the vertical direction represents the f cos theta. Okay, so therefore the normal force is going to be calculated using the formula. Students, see this diagram. This diagram represents an object is pushed at an angle theta. Okay, in certain angle the object is moving. Okay, object is pushed. Okay, then this force F is resolving into two component. Okay, with an angle theta, where horizontal surface it is F sin theta and vertical it is F cos theta. Now draw the free body diagram of this mass. So here the object is considered as a point. Then actually there will be two forces is acting. One is normal force which will be upward direction and downward gravitation is mg, and f of s, that is the frictional force. Okay, static friction is represented as f of s and the force is slightly downward to the surface. So using this free body diagram we are going to calculate the normal force of the object. Okay, now we see the derivation. Now we are going to calculate the normal force acting on an object at angle theta which is pushed. So therefore n push is equal to the downward gravitational force is what, mg plus f cos theta, because the both values are acting in the same side, so we are going to add it, so f cos theta. Now this final result represents the maximum static friction will be increased. That is, when we push the object we required maximum static friction value. Okay, suppose we know the static friction value, f of s is maximum, then we get the value mu of s into n. So here n is represented by the push, that is normal force in the push value, substituting here, therefore we get mu of s into mg plus f cos theta. So in this final equation, okay, so if we applying this much of force, so we required a greater force to push the object. Okay, so it is very difficult to push the object with greater force. Now coming to pull, see this diagram. This diagram represents the object is pull. Okay, here the force is applied above the surface. Now the force is resolving into two component. One is horizontal f sin theta and perpendicular f cos theta. So we are going to find the what are the forces acting in the object using the free body diagram. So here the block is considered as a dot and normal force is upward, and the downward gravitational force is mg, and the frictional force is opposing f of s, and the force is slightly in the upward direction. Okay, so using this free body diagram, I am going to derive the equation for the normal force acting on the angle theta. Okay, so to calculate this, the total downward force acting on the object, so which will be equal to the n pull is equal to mg minus f cos theta. Why I am using minus f cos theta means the force will be in the against the surface, so we are using the minus cos theta. Students, now you compare the normal force by the push and the normal force in the pull. In normal force in push, so we having the positive value, so that means we have required the greater force. Now compared to pull, so we having the negative value of the force, so when compared to this, we need pull an object is easier than push the object. Using this application only, when the car gets breakdown, we are pull the car with the rope with the help of another car. Okay, students, next we are going to see another 3-mark question, the angle of friction. Okay, so what is the angle of friction? We know friction. So what is angle? When an object is moving against the force, that is known as friction. At the point of the object, we are made some resultant line, so that angle between the normal force to the resultant is known as angle of friction. So when you see this diagram, you may understand. Now coming to this angle of friction, it is defined as the angle between the normal force n and the resultant force r, and the normal force is maximum value of the frictional force. Now we are going to relate the normal force and the maximum frictional force. It is represented by f of x maximum. Now see this diagram. This diagram represents the angle of friction. Now a force is applied from left to right. The static friction will be moved against the force. At the center point, the normal force is acting on an object. So between the frictional force and the normal force, the resultant force is acting. So the angle between the resultant to the normal, that theta, we are going to find. Okay, so using the resultant force, the r vector is equal to n vector plus f of x maximum, that is normal force plus frictional force maximum will be equal to the resultant force of the angle of friction. Now we are going to derive the equation for the angle of friction. From the diagram, we are going to calculate the resultant force. We know the formula already. In the addition of triangle, we know. So r is equal to square root of vx square plus vy square. That is the resultant force. Therefore here the same method we are going to follow. The r is equal to square root of f of x maximum whole square plus n square. So this value represents the resultant force. Also we find the angle, that is for the triangle we are going to find the tan theta. So we know the value of tan theta. So tan theta is the opposite by adjacent side. Here the opposite side is f of s maximum, that is frictional force, and adjacent side is the normal force. So using the value we are substituting. So tan theta is equal to f of s maximum divided by n. Then since we know the relation between frictional force of the object, what is the value? If the frictional force is maximum, means the value should be lies in mu of s into n. What is mu of s? Mu of s is the coefficient of the static friction, and n represents the normal force. Instead of this equation f of s maximum equal to mu of s into n, I rearrange this equation. So we get f of s maximum by n equal to mu of s. So instead of this value f of s maximum by n, replace in the tan theta value. So I get mu of s equal to tan theta. Okay, so this is the final equation, student, for calculating the angle of the friction. So what is the conclusion of this mu of s equal to tan theta? Now we see the coefficient of the static friction is equal to the tangential of the angle of friction, so which is represented as a mu of s equal to tan theta. That is, the coefficient of the static friction is equal to the tangential of the angle of friction. So very important 3-mark question, student. Next we are going to see another important 3-mark question, angle of repose. Now an object is moving in an inclined plane, okay, with an angle theta. Okay, so now the mass, the block will have the certain values to reach the ground. To calculate the angle of repose, we made the angle between the downward gravitational force mg and the component will be perpendicular to the block, that is mg cos theta. Between these two angles we are going to find the angle of repose. So first of all, what is angle of repose? Now consider an inclined plane on which an object is placed. Then let the angle which is in the plane making with the horizontal be theta. For small angle of theta, the object may not slide down, because at certain angle only the object is slide from top to bottom. If angle will be less, means the object will never move in the inclined plane. So therefore the value should be increased slightly. So at what angle the object is ready to move from top to bottom, that is known as angle of repose. Then this angle of repose is the angle of inclined plane with the horizontal. So the object is placed on to begin to slide. That is, at starting we are going to place the object for sliding with a particular angle theta. Okay, see this diagram. This diagram represents the angle of repose. Now the block will be moving in an inclined plane, okay, towards the ground. So here the gravitational force mg is resolving into two components. Okay, so one is mg sin theta and another one is mg cos theta. Here the mg sin theta represents parallel to the block and mg cos theta will be perpendicular to the block. Okay, now using the angle between mg cos theta and mg, we are going to find the angle of repose. Okay, now let me calculate one by one. First I am going to calculate the component which will be parallel to the inclined plane, that is mg sin theta will move the object down. And then another, the component of the force which is perpendicular to the inclined plane, mg cos theta is balanced, that is the normal force and the cos theta will be equilibrium position. Therefore we have to find the what is the static friction of this value. So we know the formula for static friction, f of s maximum is equal to mu of s into n, that is the maximum static friction of this value. And substitute where n equal to mg cos theta in this equation, so we get f of s maximum equal to mu of s into mg cos theta. So this value represents the maximum static friction of the value which will be perpendicular direction. Then we are going to calculate the parallel component value which will be the maximum, that is f of x maximum equal to mg sin theta. So divide this two value and I get the f of s divided by n, which will be equal to the normal force, and the common terms mg getting cancelled, only I get sin theta by cos theta. Since we know sin theta by cos theta is the tan theta, therefore tan theta will be equal to the mu of s. What is mu of s here? The f of s maximum divided by n is equal to mu of s, and replace the value here. Therefore tan theta is equal to mu of s. This final equation represents the angle of friction, that is the theta represents the angle of friction between the object will be falling down in the inclined plane. Now conclusion of this final equation, therefore the angle of the repose will be equal to the angle of the friction. So see the final equation, so both final equations will be equal, therefore the angle of the repose will be equal to the angle of the friction.